To keep electrical components within their operating temperature ranges, electronics engineers typically need to conduct coupled thermal fluid studies to determine the effectiveness of fans, vents, and heat sinks. However, conducting a coupled analysis can be difficult using traditional, disconnected analysis tools. NX can simplify this process. In this example, you'll see how integrating fluid and thermal capabilities into a single environment greatly simplifies how you perform coupled analyses. Here is a model of an electronic box which contains a sheet metal casing with grills to allow airflow, two PCBs each containing several electrical components, and a heat sink component consisting of a finned heat sink and several dissipating diodes. The fins increase the surface area, allowing improved convective heat transfer to the air flowing through the chassis. You can set up the analysis model in NX using the Advanced Simulation environment. Here, you build a mesh for each major component and assign material properties. The next step is to define loads and boundary conditions. Thermal couplings to connect disjoint thermal meshes have been added to allow heat to pass. Heat loads were added to diodes and other components, and flow boundary condition objects define the fan inlet and chassis outlets. The fluid mesh simulation object requests that a fluid mesh be generated at solve time. It automatically detects solids within the fluid volume that can block flow. NX subtracts these solids from the volume, and the fluid mesh will pass around these solids. This saves you the trouble of manually subtracting the solids from the fluid volume and facilitates faster analysis of what-if scenarios for the placement of components within the fluid volume. When modeling is complete, you're ready to solve. You can follow progress through the solution monitor, which tracks convergence of the flow equations. NX provides multiple out-of-the-box tools to efficiently examine your simulation results. Here you can examine different velocity profiles to better understand how air is flowing through the electronic box. You can also look at the component temperatures inside the box. The results lead to the realization that the electronic box is running too hot. To cool it down, you may want to change the design of the heatsink components. The benefit of working in an integrated environment means you can easily edit the geometry to change the model's fin size. Using synchronous technology, you can quickly extend the fin dimensions without knowledge of the part feature history. After you've completed the design change, you can quickly reanalyze your model without having to rebuild your model from scratch. As you can see, the meshes and boundary conditions all automatically update to the new geometry dimensions. You can then clone the previous solution parameters and quickly resolve the model to evaluate the new design. You can then examine the new results and compare them side by side with the results of the initial design. This helps you see more easily how the extended fins impact temperatures within the electronic box. NX simplifies electronic systems cooling simulation by coupling thermal and flow analysis within a single advanced engineering environment. NX saves you even more time by integrating analysis with design so that you can perform rapid design changes that propagate all the way through to your analysis models.